Math 3, Classwork 1.2. So I want you to first try these problems on your own. Pause the video. Now let's look at the answers. So for 1a, you should have graphed a standard parabola, domain negative infinity to positive infinity, range 0 to infinity, including 0. Now over here in part B, we are multiplying by negative 1/2, multiplying outside the function vertically stretches or compresses, and it's multiplied by a negative. And when it is affecting it vertically outside the function, it does exactly what it says. If you're multiplying by 1/2, you are compressing. You are compressing and flipping with the negative sign. Now, notice in part C, I have the multiplication by negative 1/2 there still. The change is the plus 2 minus 4. When you are adding or subtracting to the x inside the function, you have to actually look at the opposite operation. So you are thinking subtract 2, opposite of addition, left 2. When the arithmetic is outside of the function, do exactly what it says. Minus 4, subtract 4, and that affects it vertically, bringing it down 4 units. And you are also being asked to describe the transformation with words. So those are a couple of ways you can do it. Now, if you have not yet done number 2, pause the video and do it. I'm assuming you have already tried number 2 on your own. We have the square root graph, domain and range. Then for part B, we are multiplying by 3. So multiplication outside the function, vertically stretching it by a multiple of 3. So what was y value 1, y value 2, these are now y values 1 times 3, 2 times 3, but still with the same x. In part C, the multiplication of the 3 is still there. The only change is you have now a minus 1 and a minus 2. If the addition subtraction is inside with the x, opposite operation. You see minus 1, you need to add 1 to the x's, so that will horizontally move it right 1 unit. And then the minus 2 is outside of that square root. So being outside that square root means that it will do exactly that vertically, and you move it down 2. Now, if that was easy for you, that is fantastic. If not, we'll keep going. We'll keep trying. All right, now, everybody, bring your video back in. If you had fast forwarded, now's the time to listen again. Okay, so inverses as tables, inverse relations as tables. Two functions are inverses of each other if every ordered pair being xy. All an inverse function does is it swaps the x and the y, and it forces it to go backward. Now, if you are trying to find the inverse function through a table of values, as example 3 is doing, then all you are doing is just taking them and swapping. What was negative 2, negative 13 is now negative 13, negative 2. The next thing that I want you to do is go through and plot these points. So you're going to pause the video. You are going to plot all of these points. And now you're back. I'm assuming you have plotted these points already. Now, make sure that you also plot the prime ones. So basically that means you are going to take what you got in this table and plot those points too. Now for the answers. Here's what you should be seeing. And as far as interesting patterns, do you feel like you could almost draw a line? The line y equals x. Now, the line y equals x goes through this purple point. It's purple because what do the colors red and blue do when they come together? They make purple. So it is its own image. If your x and y coordinate of a point are identical, then flip-flopping them isn't going to make any difference. And so they are reflections over the line y equals x. Now, make sure you write down this very, very important fact. And I'm already showing you the answers. So now, everyone, with number 5, you are trying to draw the inverse graphs. Start by drawing the line y equals x. Just a nice gentle line y equals x. Not perfect. And then I'm going to change colors for drawing the inverse. So where the original function crosses y equals x at -3, -3, that is the only point that is shared between the original function and its inverse. You are now drawing a reflection of that original line. So it looks like it has, the original line has an x-intercept of about -1.5. So I should see somewhere around -1.5 on the y-axis that the inverse function has a point. And I can see on the original function, it looks like you have a y-intercept of 3. That will change to an x-intercept of 3. And then do your best drawing that line, especially on a screen. Part B, also start with drawing y equals x. Then you want to draw the inverse. Start with where that graph intersects y equals x. That is where the original graph shares a point. Then look for x-intercept, y-intercept of the original graph. I see a y-intercept of the original graph at 8. So y equals 8 is going to turn into x equals 8 as an x-intercept. Now, if you're just drawing a line, all you need are 2 points. You got 2 points now. So connect the dots. And voila. Let me show you what the answer should look like in a nicer version. There we go. Now, see if you can do C and D on your own. Pause the video, try it. All right, if you're having trouble, I'll talk you through it. So let's start with draw the line y equals x. I don't expect it to be perfect. I'm having trouble even drawing it perfect myself. Yeah, okay. Then I want to look at where the graph touches y equals x. So it crosses y equals x about here. It crosses the line y equals x. Should be crossing it about there-ish. Again, I don't expect you to be perfect. I can't draw it perfect either. Now, because this is a parabola, it would help to locate the vertex. For the original graph, the vertex is the point x equals -2, y equals -6. So that means the reflection point for the inverse graph will be swap that. And now I look at x equals -6, y equals -2, giving me this point, and that is the vertex. And with 3 points on a parabola and knowing which one is the vertex, you are ready to start drawing. But if you're a little uneasy, you can add in x and y intercepts. It looks like the original parabola has a y-intercept of 2. Y-intercept changes to x-intercept of 2. That was -2. Important to pay attention to those negative signs. So here's another point on the inverse parabola. I see an x-intercept of about -4.5, so y-intercept of about -4.5. And it's starting to take shape. And if you have an up or down parabola and you look at the inverse, it should turn into a sideways parabola. And then my lovely drawing. Part D. If you think you might be able to do it, pause the video. And now I'll walk you through it. Let me get rid of this excess. Start by drawing the line y equals x. Then, anywhere y equals x crosses this parabola, those are points that are shared with the inverse graph. I see a vertex. The vertex on the given graph is x equals -5 with y equals 2. So now I'm going to just reverse 2, -5, find the point 2, -5, plot it. That is going to be the vertex of the image parabola. I'll put a V for vertex. Now, at this point, you have 3 points. You might feel comfortable drawing it. Maybe you need a little bit more. So let's look at intercepts. The original graph has y-intercepts just a little greater than -3 and a little less than 1. Y-intercepts turn into x-intercepts, and that was a little greater than 3 and a little smaller than 1. And keep in mind, this is not a perfect drawing because it's not a perfect drawing. You can see that it looks like the original graph might have a x-intercept of 10, so y-intercept of 10. And if you know this is the vertex, and you know a sideways parabola turns into a right side up parabola, and understand, I am not looking for a perfect drawing. You're trying to show me that you understand the relationship of changing a graph into its inverse visual partner. Okay. Now, next, inverse relations as equations. So you may have done this before. Maybe you've entirely forgotten how to do it. The first thing you're going to do is switch the x and y variables. Then you're going to isolate the new variable. So let's do one of these together. So we're going to start with, I'm going to change over to a red color. I'm going to make the y become an x, and I'm going to make the x become a y. And then everything else, I'm keeping exactly the same. And now my goal is to isolate the y. When I'm isolating a variable in an equation, I am looking for weakest operation. Weakest operation is subtraction. So The opposite operation of subtraction would be addition, so add 1 to both sides. And now to continue isolating y, I need to take care of the multiplication by 4 by doing the opposite operation and dividing both sides of the equation by 4. So x plus 1 over 4 is the inverse function. And we denote inverses with a little -1 that looks like an exponent, but it's a symbol only. It's not actually -1 itself. It's not actually an exponent. It's just a symbol saying this is the inverse function. Unfortunately, sometimes math reuses its symbols to mean something different. Now, pause the video, try part B. Okay. Now, maybe you just want to check your answers. So your answer for part B, right there. And so if you need a little bit of help getting through that, again, you first switch the x and the y, and then your goal is to isolate the y variable. Look for the weakest operation, addition, so you're going to first subtract. So subtracting the 6, then y is being multiplied by -3/4. And anytime you're multiplying by a fraction, the easiest way to undo it is to multiply by its reciprocal. So multiply both sides by -4/3, and that will undo that -3/4 multiplication. And that then is y isolated, and you have your inverse. Now, try part C on your own. Pause the video. If you need help, I will take you through it. So I'm going to start with, you need to swap the x and the y, but make sure that you keep everything else exactly as it is. And now your goal is to isolate y. This -1 outside the parentheses is your weakest operation, so it's the first thing to undo with the opposite operation of add 1. Now you have a parentheses, strongest operation, an exponent next down the list, and multiplication. Multiplication is now the weakest operation. It needs to be undone with the opposite of multiplication. Divide both sides by -2. And at that point, now the variable we're trying to isolate, y, has addition in a parentheses and an exponent. Exponent is the weakest operation. To undo a third power, you are going to do the opposite operation, which is a root. You are going to cube root both sides of the equation. And then you will have a last operation there. Let me show you on the answer sheet. Now, when you take a cube root, unlike square rooting is dealing with an index of 2, where this is an index of 3. Only if you root with an even number do you have to bring in plus or minus. And again, we will discuss why that is an issue in a later section.